What's up, guys? Welcome back to the channel Easy HVAC, where we talk about all things HVAC. Hope you guys are having a fantastic day. It's Friday, day before the weekend. Hopefully you guys are, it's an easy day for you guys, and you get the weekend off. You can have that time for yourselves, for your family. R&R, a little R&R is definitely important to keep going, especially in this industry. So but today I just wanted to show you guys how to check a fuse. Now, a lot of you out there probably already know how to check a fuse. It's pretty simple. It's not very difficult. But for those out there that are, do-it-yourselfers or curious homeowners, for those that are considering becoming an HVAC technician or an electrician, maybe those that are, starting electrical engineering or going to school for electronics, this video is more for those individuals. But yeah, I'm just going to show you guys just how to check this real quick. But what is a fuse? Well, a fuse is a electrical safety device that is designed to protect electrical circuits from overcurrent. Okay, so basically the fuse consists of a metal strip or wire that melts whenever the current is too much for what the fuse is rated for. So whenever the current is too much, again, it melts that wire or that strip, and at that point the fuse opens the circuit. It disrupts the circuit. And a fuse is unlike a breaker. A fuse, whenever a fuse breaks, you have to replace the fuse. You can't reset a fuse like you can reset a breaker. But it is there for safety, to protect those circuits from overcurrent. So here's our fuse. The way we check our fuse is obviously with a meter, multimeter, and we're going to be checking our fuse with ohms resistance. So resistance is just the opposition to current flow. Resistance is measured in ohms, right? So we're gonna check this fuse with ohms or continuity, and if I can get it to stay still here. And we're gonna see if this fuse is good or bad. So we're gonna take our meter, we're gonna set it to continuity. A lot of you guys are probably used to continuity and hearing the beep, but continuity, when we test for continuity, we're testing whether or not the circuit is complete. Do we have a complete circuit? And so whenever we connect our two leads, basically what's happening is our meter is sending a small current, from one lead through the fuse into the other side, and that circuit is complete if the fuse is not broken. And that would be the same not just for fuses, but switches as well. We use continuity to test wires and many other things, but we're just going to take your two leads. So I've got my meter set on continuity. You're going to take your two leads, and if this circuit is complete, if the fuse is good, you're going to hear a tone. So you hear that? See if I can get it to connect better. Hard to do this with one hand, but give me a second. All right, so the fuse is good, and I want to show you what that looks like on the meter. Alright, so you see how we have 0 ohms? 0 ohms of resistance. So what that means is that circuit is complete. We have no resistance, meaning we have no opposition to current flow. So current can flow freely through our circuit, through this fuse. Now, notice right now the meter is OL. So if we were to connect our two leads, So if we were to connect our two leads to the fuse, one on each side, and we got this OL, that would mean that the fuse is broken, right? The metal wire or the strip has melted, and we do not have we no longer have a path for current to flow. OL means open circuit or over limit. It just means, you know, extremely high resistance. So much so that current cannot flow through this fuse. So yes, if you were to get a reading like this, whenever you took your two leads and touched each side of the fuse, that fuse is bad, right? So we now know what a good fuse looks like. 0 ohms and a audible beep if we had our meter set to continuity. If you had your meter just set to ohms, your meter wouldn't beep. But you would still get 0, which means, no resistance, right? Or 0, very, very low, meaning that we have no resistance to current flow. Current can flow freely through the fuse. All right, we have a complete circuit. Nothing is open, right? So that's without our meter set to continuity, but just using ohms. So whenever it comes to fuses, switches, you definitely want low resistance so that we can have current flow. But that's pretty much it, guys. It's pretty straightforward, and fuses come in all shapes and sizes. I mean, there are low voltage fuses that are rated for 5 amps, 3 amps, and then of course there are high voltage fuses which are a lot bigger than this. The amperage range can vary greatly. So. But it's the same principle though, as far as checking a fuse. Even if this fuse were a big fuse rated for, say 70 amps, like you might see in a disconnect for a unit, the method of checking that fuse is still the same. You would still check it the same way. But of course, whenever you're checking or testing electrical equipment, always make sure that the power is off, and confirm with your meter that the power is off. So guys, that's pretty much it for today. Hope you benefited from this video in some shape or form, and I hope you guys again enjoy the rest of your day. If you like the video, please like, subscribe, hit that notification bell, and I'll definitely have more videos coming your way. Thank you guys, I appreciate it, and we'll catch you on the next one.